Have you ever wondered what you need to crush a soda can with some magic and a little bit of chemistry? Well, if so, let's find out. To get started, we'll go through what equipment and supplies you need to crush your cans. First, you're going to need some soda cans to crush. Second, you're going to need a range or stovetop to heat your cans with water. Third, you're going to need a bucket full of cold water. And fourth, you're going to need a little bit of cleverness and a lot of bit of magic. Alright, and now on to the procedure. So the first thing you are going to do is you're going to add 10 to 15 milliliters of water into your soda can. You're then going to turn your stove on to high, and you're going to place your soda can with the water in it on the stove top. Wait for the water to boil. Here we've sped up the process quite a bit. Make sure you're watching the whole time, and then eventually the water will reach a boil. After the water has reached a boil, let the water boil and the steam vent out of the can for 10 to 15 seconds. After you've let the water boil for 10 to 15 seconds, you are now going to grab the can using tongs, turn it over, and immediately dunk it into your cold water bucket. And just like that, we can see, poof, the can has magically been crushed. Let's take another look and do it with another can. Whoa! Oh, just like that. Slow-mo. Let's take it slow-mo. And bah! Even in slow-mo, it's so darn fast. And as you can see, we can do it with large cans. Take a look at that large can in slow motion. Pa! Oh, it's so good every time. And you can see the carnage. The can is completely flattened, just with that magic little step. And you can see the carnage of our experiments. To think about the theory of what's going on with this soda crush, what we first have to do is we have to consider the soda can right after we've added a little bit of water. So what we're going to do is we're going to look at that with a magic magnifying lens to help us kind of zoom in and consider just the air molecules and water molecules. So here we're just representing them as spheres, and remember this is a very approximate model. The numbers that we usually deal with are in the tens of trillions, but in order to help us comprehend, we've tried to simplify it a little bit. So initially what we have is we have the liquid water at the bottom of the screen. And in addition, we have water molecules and air molecules throughout. What we're going to do next is we're going to add some heat. And what adding heat is going to do is it's going to help turn that liquid water into gaseous water or steam, right? So steam is water in a gas form. And so what happens when that liquid gas turns to steam is that all those steam molecules will be moving really, really fast. Remember that temperature and kinetic energy are related, so all these really fast moving steam molecules are going to want to take up a lot of space. And in order to do that, they need to push out a lot of the air molecules that were already in the can. So then what we do next is we take the can, we're going to invert it into the cold water, and what that's going to do is it's going to seal off our container, right? So no air can get in through the water. And additionally, by submerging it in cold water specifically, what we are going to do is we are going to very quickly condense all the steam or all those gaseous water molecules into liquid water. And what that results in is inside the can now, where there were once a bunch of water molecules or these gas particles, right? Just thinking about the number of gas particles inside this container, our soda can has gone almost to zero. Basically, the pressure inside now, the number of collisions against the inside of that can wall has pretty much gone to zero, which means that the internal pressure, the force in total against the can, is very little. And this is going to lead to the can getting crushed. So what we basically see here is that the cans get crushed. But you might be wondering, why does having nothing inside result with the can getting crushed? And there's a really interesting point, and something we forgot to mention this whole way along in all these drawings. And that is that there is air surrounding the can. So that means when the can is open, the amount of force pushing out on the can is the same as the amount of force pushing in. But when we remove that pressure inside, we remove that amount of force pushing out. And this incredible thing, this air that we're surrounded by, is actually a very, very powerful force, and it's able to almost instantaneously crumple the can itself, which is a really, really interesting thing to think about, right? You are surrounded by this force all the time. You just don't feel it because your body is equally forceful on the way out. I would say we really crushed it with this lab demonstration.